We are going to make our first experiment. This is Daniel and you are going to get coded. I hope you have seen this video. If you haven't watched this video yet, please watch it, because in that video I showed you how to implement Quicksort. And I have the code here from that specific video. So I'm going to continue on from that code. So make sure you watch that video, you get the explanation, you get the code, and then you can come back here so we can continue on. If you have, you are welcome. Let's continue. So as I said, I'm going to make an experiment. I'm going to compare my algorithm with Microsoft's in terms of performance and speed, and see how they actually run and how fast they run in milliseconds. Okay, so this is like the idea of this specific video. Okay, so you might be thinking, should I use this algorithm to store my arrays? And if you press on this link, you will go directly to that generic algorithm. But well, yes, if you want that, but .NET comes shipped with a sorting method for arrays called Array.Sort, and you know that already. So let's begin. Array.Sort uses the introspective sort, which is a combination of insertion sort, heap sort, and quicksort. So these three algorithms. So instead of merge sort, heap sort. That was the one which I missed in that video. The algorithm becomes more efficient, being optimized based on its size and partitions. So this is the idea of this introspective sort. It is optimized based on these two variants, these two dimensions, these two characteristics of the array. So use Array.Sort. You don't have to implement anything, you know that already, and it's much faster than if you would. Don't trust me? Let's experiment it. So I'm going to create a function to return an array of random integers. So this function, random numbers, returns a random array of numbers. So let's go one by one and see what I do here. I pass a size, a minimum, and a maximum. Then I create the array with that specified size. Then I create a new random object. And based on this random object, I can call the .next with min and max to actually get a random number. So this is how random works. You create a new object of the random class, and then you can call random.next, to which you pass minim and maxim. So 1 and 5, and it will give you numbers in between those numbers. Okay, and here I use a for loop because I want to continue to repeat actually this step, size, a total number of size. So if I pass the size of 10, this will repeat 10 times, so it's going to add 10 items to the array. Okay, so this is like how many steps we want to loop, how many steps we want to create random numbers, and then we can just return the number. So I'm going to create this after the main method, and I'm going to pull this to the left a little bit so that I have enough space. So let's begin. So private static int square brackets random numbers, and then I'm going to pass, as I said, int size, int min, and int max. So these three parameters. Then I'm going to create a new array. So var array is going to be new int, and I'm going to pass the size. So whatever size I pass, that size is going to be put in the array, and the array is going to be that long. And then I'm going to create a random number. So random object, actually, not number. And then I need a for loop. So for tab, I will leave I and then size, and I'm going to say array index I is going to be random.next, and I'm going to pass min and max. So the numbers again are going to be in between these two integers. And then I'm going to return the array. Again, you can see I use a set of extra curly braces on these two lines. It's fine, you can leave them if you want to, but I prefer having them because they provide a better readability to my code. So this is how I like to code sometimes. But you have two options, you can choose your own. You can pass a size, how many items, as I said, a minimum, the minimum starting value, and the max, the maximum ending value instead of starting. Okay, so I have a typo, a problem there. So the maximum ending value. I will create 2 million numbers ranging from 0 to 500, and there are going to be so many duplicates. Why? Because there are only 500 numbers in between these two, right? So 0 and 500, there are going to be 500 numbers, but I'm going to create 2 million numbers. So it's going to be a lot of numbers which are the same, so like 2, maybe 100 times, I don't know. So this is what I mean by duplicates. So I'm going to call this specific method here. So instead of creating and initializing my own array with these 6 numbers, I want to call the random numbers. So I'm going to pass 2 million, so 2, 3 zeros and 3 zeros, and then I'm going to pass the starting point and the end value. So the boundaries start at 0, ends at 500. Okay, and I have to get used to I have to get used to having the mouse over here. So I moved it on the left side. Okay, so I'll create a new stopwatch to check how much time it takes. So this is how you actually test, how you actually count the time. You can use the stopwatch. I will start it by before sorting and then stop it after sorting the array. Then I print the time. So let's do that. I'm going to create a var watch, and this is going to be stopwatch with lowercase w, and let's try control dot using system.diagnostics. Okay, so we need that using statement and then start new. And this is similar to, well, the idea of this method, if you want to know, this is extra. The start new is a factory function because we don't have new. So whenever you have new, you are actually initializing an object. But here you are actually using a factory method, okay? And this creates new objects of type stopwatch in our case, but you can create your own, which returns your own thing. So just a side note. Okay, so I create this one here, watch, and then I say sort array, and you can see here I use the actually built-in version. So let's try to use the built-in version first. So Array.Sort, this is how you sort arrays, and then watch.stop. Okay, watch.stop, and instead of printing the actual numbers, because we are going to have 2 million numbers, so make sure you remove that because it's going to be like just so crowded, so many new lines in your console. You don't want that. Instead, we are going to print the time. So we are going to say watch.elapsed milliseconds. So this is the total time in milliseconds which has passed. And then CW tab, and then time with Array.Sort. Okay, so we want to print a message. So $, quotation marks, these ones, and then new line, time with Array.Sort to be specific, and then curly braces, we need to pass the time, and then milliseconds. Okay, so it says here that it took 365 milliseconds. Let's try to see this time how much time it takes. It takes 166. Why is that? Why is so much difference? 166. Maybe I have a problem over here. Maybe the first time when I wrote this, I said my own instead of saying Array.Sort. So let's leave it like this. I'm going to continue. Let's try to compare with the built-in function, okay? So this is like the actual problem. Instead of Array.Sort here, I actually used my own. So sort array. And if I press F5, you can see 317 milliseconds, quite close. So many times it runs differently and it yields a different time. It can range for a couple of milliseconds. Maybe this will be different, and not maybe, but almost 100% is going to be different on your machine. So what we have to keep in mind is by using the sort array, and I have to change the name in the message as well. By using my own implementation, I have a total time of 317, so above 300 milliseconds. So this is what you have to keep in mind. So let's press any key. I'm going to rename this, or to actually replace this with sort array. So this is what I'm going to actually test. And let's continue. I will copy all the random numbers to another array because I want to have the same numbers to work with. Okay, so if I call this again, I want to have the same random numbers. So I want actually to copy them to have like a very, like the same kind of numbers. Because if you just pass the numbers to the sort array, it's going to be sorted, right? Obviously. And whenever you call the second time, so I cannot just say sort array there and then Array.Sort again, because it's going to sort the same array. And I want to copy them, because if I just call random numbers, it's going to create another array of random numbers, and they are not going to be the same. So to have a more, I don't know, a better testing environment and to have like proper results, I want to have like the same array. So this line is the same. I'm going to create a new variable called copy, and this copy is going to be actually a new int, a new array, again 2000 and then 3 zeros to million numbers. And then I'm going to say array.copy. This is the method to copy two arrays, so the contents of one array to another one. Array.copy. I'm going to pass numbers, I'm going to pass copy, and I'm going to pass 2 million. Okay, and also you can see that we are going to repeat ourselves. I hope I have later on a refactoring for this one. So way too many times I repeated myself 2 million, 2 million, 2 million, too many times. Okay, nevertheless, we can continue on. So var watch and then sort array, watch stop. Okay, I'm going to print that. And then I'm going to do actually the same. So watch is going to create a new watch. So stopwatch, I'm going to use the same variable. So I don't have to declare a new variable. I can just create a new object there. And I can say array.sort. I want to sort the copy of that array. And let's try to get the time again. The same variable which we declared before. Watch.elapsed milliseconds, and then we are going to print to the console. I want to copy, so you can copy this line over here, Control C, and then move down, Control V, time with array.sort, and save. I'm going to remove these new lines, and let's try to press F5 and see if we got it right. Okay, so you can see the actual difference. I'm going to actually change the properties over here to 36. So you can see the time with sort array 362. So right now it got more. And then time with array.sort 159 milliseconds. So actually 2.5 times faster, I think. I don't know. So like this is the actual differentiation. So in our sort array we use Quicksort. So our own implementation, our manual implementation, procedural implementation of Quicksort. But in Array.Sort they use an introspective algorithm, an introspective sort, which combines quicksort, heap sort, and insertion. So this is the actual differentiation. So even though you want to take your time to actually implement quicksort, it's not going to be faster. So you have to actually create a better algorithm than what Microsoft has come up with. So good luck with that if you want that route, but there are many other things in programming that you should be concerned about. So this is just an experiment to show like what is the difference between these two and why you should not actually implement Quicksort. So whenever I hear from companies that they actually want to implement Quicksort, I am like, really? This is already built in. Why do you want me to build Quicksort? There are just so many things I can do as a programmer. I can learn new technologies. I can learn new frameworks. I can do amazing things. I can create something for you. I can just grow in so many other ways than to just have, I don't know, to just fill my mind with a Quicksort and how it works. So it doesn't make sense for me. This is why I tend to not like this kind of companies which just asks you procedural programming and just Quicksort and all those things. So my advice for you, if you are into coding and if you want to evolve, try to learn as much as possible. Try to watch tutorials and videos and read books if that's your case, but don't read books in the beginning because they are going to be way too much, with so much fluff, and I don't like that fluff necessarily because they overcomplicate things. I don't know only C#. I have to know so many other programming languages. So make sure you don't waste your time. Make sure you learn the right things. I will try to show you guys the right things that you need to learn because I value your time. I value how you work, what you do with your time. And even though I might post longer videos, I post them because I have to explain. If I just explain in 5 minutes, you will not get anything. So this is my actual viewpoint. I want to explain everything step by step, so that you can know, so that you can create your own program, so that you can be a great developer when you want to have a job or when you want to create your own personal project. Okay, so let's press enter and let's continue on. Here's the result. So they are kind of different, but again, also I wrote here more than twice that time, or exactly 2.49, so almost 2.5 times more with your own implementation. So let's try some refactoring. To not repeat ourselves, again, keep our code dry. We can refactor our code by extracting a function for the stopwatch. So let's do this. This is an extra step, but this again, I want to stress the idea of actually have a clean, elegant code, a refactor code. These things are very important. You need to have a clean code which can be understood, which can be easily read by anybody else, okay? So this is what you should strive for. Maybe you don't know everything in C#, maybe you don't know anything inside programming, but if you take your time to actually write amazing code and clean code, you'll be one step ahead of many developers who actually have more experience than you and don't write code the way they should, okay? So actually after print main, I'm going to create this one. So private static void, I'm going to say print execution time, and this is going to be action. So I'm going to pass an action. This action holds a method. Okay, this is how you can pass methods. Right now I was passing integers and arrays. If you want to pass a method, you can use an action. And then I can say var watch. So I'm going to actually cut and paste the code from here. So you can see I want these two lines from here, and the middle line is going to be a new one. So I'm going to copy these 3 lines and I'm going to paste them over here. And instead of sort array, I'm going to say action.invoke, and this action is going to invoke that method. So whenever you want to pass a method through an action, that method is not going to be called until you call that invoke. When you call that invoke on the action, that action is going to call a method. So this is how you can actually call a method later on. Maybe you don't want to call the method right now, but you want to call it later on. You can just pass it through an action to a method, and then that action, on that action, you can say that invoke, and that invoke is going to call that specific method. Okay, and then we are going to print the time. So I'm going to say this time over here. It's fine, and I'm going to put this time afterwards. And I think I have a problem over here, Array.Sort. Yeah, I don't know what's going on there. And also here I copied the second thing, so you need var, because right here I was using the actual first time. And we can call this function by constructing a lambda expression with the sort calls. So you can call that method and you can pass the lambda expression. So parentheses, fat arrow, that fat arrow is called, or you read pass to sort array numbers. So let's actually do that. So basically, I'm going to remove what? Or what am I going to remove? So the time I don't need, so I don't need any of this right now. So you can see the code got smaller, and I don't need this one either because I construct the watch there. So I have numbers, I have copy, and then I want to pass both of them. So I'm going to say print execution time. I'm going to pass I'm going to pass parentheses, then fat arrow, and I'm going to call the method like this. And again, this method is not going to be called there on this specific line. It's going to be called here when we call that invoke. Okay, I'm going to copy this line, copy, C, Control C, Control V, paste. Instead of sort array, I'm going to say Array.Sort. And because I don't actually want to do something here, I could have done like an extra parameter here to actually pass the name of the method, but I'm not going to do that right now. So to keep our code like simpler, I'm just going to print the time. And we can know, not we can know, but we actually know that the first one is going to be our own implementation. The second time is going to be Microsoft's implementation. So let's try to actually run again to see if our refactoring got well. So it's kind of nice. Let's try one more time because I think it's way too low. Okay, so the first time got way low, but right now faster. So again, there is so much differentiation, so much difference in time because we use random numbers, and sometimes if you have duplicates, a lot of them, then it's going to be easier. I don't know. So this is how it works when you use random numbers. So it's again an approximation. It's not like 2.5 times faster. It's going to be a range. I don't know. So in order to have that, you need to have like a broader perspective, a broader range of values which you pass, and then you have a broader or more precise approximation of what the algorithm actually performs. So this is not the object of my work right now. So as you saw, I just removed the message. So if you want to pass the message, you cannot get the method name here. Let's try to see. So I'm going to find like action dot. Let's try to see what the action is here. So we can have a method. And can I get the method name over here? So let's try to print this out. I'm going to say CW tab. I'm going to pass this method name. And let's try to see if we actually get the method name. If we get the method name, we don't need an extra parameter. We can get through reflection. So let's try to press F5, and I think this works. No, it's main. Okay, so it's not like that. I don't know. So I don't know from the top of my head how this works. I want to get like actual sort array in Array.Sort, so I cannot do that right now. Yes, so if you know how to do this, you can write down below. I haven't actually spent time to actually think about it and how to use reflection to be able to call this. So yeah, guys, I don't know right now. So maybe if I have some time, I can actually write it and I can make a new commit to the GitHub repository, and whenever you clone, you are going to get the full solution. So you are going to get also this one through reflection. Again, if you don't want to do it with reflection, you can just pass like the name of the method, so string method name. But this is, again, is not that professional to pass the method name, and I'm not going to do that because it's going to change the lambda expression as well. So again, give me some time. I'm going to see how this actually works, and I'm trying to get like the actual lambda name expression from that one, and then I'm going to update the repository. So let's conclude this video. So as I said, the Array.Sort is more optimized and uses 3 different sorting algorithms. I hope you like this experiment, and my advice is to use the offered functions or methods and not build the wheel if it's not strictly required. So if you have a very, very narrow specific requirement in your company, in your job, in your personal project, don't waste your time on these things. Try to build something meaningful, something which adds value, not just a Quicksort, which has been done over, I don't know, thousands and thousands of times by developers. Again, you can find the source on GitHub as well. And until next time, see you guys. Bye.